welcome to Blow Your Own session 4. We're working on adding a sensor onto our circuit board today, so we can control the lights just with our ambient surroundings. And we've got the regular team back. So we've got Sophie and C and the Rutherford Appleton laboratory. We've got CJ, who is going to be doing our creative. Sarah from Science is going to be helping do the round. If my sound's a bit dodge, I'm just gonna be quiet, and I will pass it straight on to Sophie, and we'll get on with the lesson.
Okay.
Is that all right?
That works for me. Thank you, Dave. Hello, everybody. It is lovely to see you all again. I've been having so much fun doing creating some Christmas coding for you with you all. And so thank you for coming back and doing more stuff with us. So today, last week, I'm sure you'll remember, we turned our LEDs on using a button, because LEDs that are always on are annoying. But I'm really lazy, as are a lot of scientists and computer scientists, I think. And so we like things to happen automatically. So what we're going to do today is we are going to have lights that turn on automatically when it gets dark. And this is one of my favorite bits of it. CJ, do you like this bit where you just get light in the darkness?
Yeah, this LDR photoresistors, I think, are my favorite sensor for sure.
Yeah, they are really cool. So we're going to use a sensor called a light dependent resistor. And that just, it measures the light around you. And then it sends some information back to the Arduino. It tells the Arduino how light it is, and then the Arduino can use that to decide whether or not it's time to turn the LED on. So like before, what we'll do is we'll build the circuit, we'll build it in Tinkercad, and CJ will build it in real life, and CJ and I will talk a little bit about the light dependent resistor and why I think it's my favorite too, you know. Yeah, I really like it. And then I'll make your own. We'll code them all so that they work. All right, so everybody to Tinkercad. Do you need a reminder of the class code? Sorry, I should have had that ready, shouldn't I? Here in the chat, I have just popped the class code in. So the chat has the class code. If you click on that link and then put in your Tinkercad username, that will take you to Tinkercad, and then we can get started with our coding. So I'm just going to share my screen. And you are all old hands at this now. We're going to, again, use all of the things that we have learned in the last 3 weeks. So we get ready, we create a new circuit like this. And then we wait because Tinkercad's apparently being slow today. Here we go. And we're going to use an Arduino. So bring out your Arduino and bring out your breadboard. Everyone give me a wave if you're ready to start, if you're here with me or if you're still getting onto Tinkercad. CJ's with me, that's awesome. Or was that you have a question, CJ?
Just thumbs up.
Oh, awesome. Thumbs up. Brilliant. We've got some thumbs up. So yes, do a reaction, a thumb up or a wave or a smiley face or something. And then, oof, there seems to be like a chicken leg or something that you can do as a reaction. Everyone find the best reaction that you can, because this is awesome. All right. So we are going to start with the circuit. We're going to use the same LEDs that we did before. Ooh, I love the wave. We're going to start with the same LEDs that we used before. We're going to have 2 LEDs and they are going to light up when it gets dark. So bring your 2 LEDs over. One over here and one over here. If you do want, you can just copy the circuit from your circuit from last time, because the LED bit is going to be exactly the same. Although I think I'm going to choose a different color LED this time. You remember you can change your LED's colors. I'm going to have a yellow one and a red one, I think, like this. Right. Once you've got your LEDs on, we want our resistors. So you pull your resistor over like this. Can anyone pop in the chat how what size of the resistor, what resistance we used for the LEDs? Can anyone remember? Yep, Isabel, fantastic. 220 some wire. Oh, you're all great. You know what? I think maybe next time CJ and I should just have a rest and we can get them to do all of the stuff. I think that would be a great idea.
Yeah, definitely.
Yep, sounds good to me. Oh, all right. So I'm just going to change my resistance here to 220 ohms. Do remember to change that ohms, otherwise it will be far too big. Your LED won't shine. And another resistor for my red LED, like that. And then I want to connect my circuit to the ground. So remember, from this minus line, I'm going to go all the way to the ground. And you remember that I was using color coding for my wires, so I'm going to use a black wire going to ground. So nearly there for my two circuits. We just have two more wires to do. One wire going from my yellow LED, and that's going to go to pin 11. So that's not a very pleasing straight wire, is it? That's better. Dane's laughing at me, everyone, because I like straight wires. It's just better that way, Dane.
Very neat, very neat.
Thank you. And my wires are green going to LEDs, remember, because that's an output. And then I'm going to do one more wire that goes to my other red LED, like that. All right, everyone, give me one of your exciting emoji, exciting reactions when you are there and ready. Fantastic. Bilal is there. Irish. Oh, we've got a party. Oh, there's a snowman, everyone. I love these reactions. We've got some parties and a rocket ship. That's very appropriate. Sarah's got a ghost and a pumpkin. This is fantastic. I mean, mainly fantastic because you're building the circuits, and that's great. But I do love the reactions as well. Right. Okay, so I think most people are there or had just duplicated their circuits beforehand as well. So what we're going to do now is we are going to get our light dependent resistor. Right. Oh, sorry, I've lost my screen. Now, if you can find your light dependent resistor on Tinkercad, if you just scroll down all the way here, and then you see this one called a photoresistor. Okay, photo is just a fancy way of saying light. Often we often use photo when we mean light. So you take your little photoresistor and you bring it over here. CJ, do you want to show everyone a real life photoresistor? Hang on, I'm just going to spotlight you for everyone. Yeah, so can you see it? It's got a nice wriggly pattern on the top, and it's got really long legs. Thank you, CJ. Okay. Now, to make it work, obviously we need to connect our photoresistor to our Arduino, and it actually works really quite like a button. We're going to connect it to some power, just like the button, and we're going to connect it to some input, and we're also going to use another resistor just to make sure it works properly. Right, so first stop, let's connect it to some power. So you'll remember that before we connected this whole row, this plus row, to the power. So I'm going to go draw from the plus row all the way down to the bottom of the Arduino and to the socket that says 5 volts. like that, 5V. So it gets that extra power that it needs. And because this is power, I'm going to use a red wire here. Okay. And then we need to connect our red power up to our photoresistor. So I'm going to click from that red line and connect it to the column that the photoresistor is on the right. So just here, there. All right, so we've got half of it there. And then we're going to use another resistor, just like we did with the button actually, to reduce the amount of current and connect it back. So we go back up here to grab a resistor and we connect it to the ground row, so to this minus row here, where the other resistors are connected to, and to the other leg of the photoresistor. Okay, is everyone there? Give me a reaction if you are at this point. And don't worry if we're going a little bit fast, because remember, this is all recorded and you can watch the recording, you can pause us and go on as we, and do it again at your own pace if you want. Ewan and David have got their Ewan and Dave fab, Isabel's there. Arish, well done. Ben's got a tick. Oh, Sarah has a ladybird. That's very pretty, Sarah. Brilliant. All right, so while we're just waiting for a couple more people to give us a reaction and show us that they are ready, we'll just trace through the circuit. We're going from the power up to the red row on the breadboard, from that to the photoresistor, and then from the photoresistor back through this other resistor, and then to the ground. All right. So we have one more wire, one more connection that we need to make. And you'll remember last time we had almost exactly this, but with a button instead of the photoresistor. And then we connected the button to one of the pins on the Arduino so that the Arduino could then tell whether the button had been pressed or not. And so we need to do that same thing again, but it's a little bit different this time. Do you remember how CJ and I were talking about digital pins and analog pins earlier? CJ, do you want to explain the difference between them just so that everyone remembers? Because we're going to use a different one this time.
Yeah, so we've been using digital pins previously, as Sophie said, and a button, for example, last week, and I think it was just last week, used a digital pin. And that's because the input is digital and it's either on or off. And it's very specific about what it can and can't do. It's either on or off or 1 or 0, kind of quite binary in that sense, either or. Whereas with the analog inputs, it allows for like a variation in the inputs. So instead of it being 1 or 0 or on or off, we can get a range. Sorry if my video is lagging a bit, but we get a range of numbers. So instead of 0, 1, we can have 0 all the way up until 200, for example. And we can input into the code, which Sophie might explain, and you'll see that there'll be a range of numbers. We won't just be using high or low or on or off. We'll be using a range of different numbers, and that's sort of the difference. And because light can be seen at a range of intensities, that's why we're using this the analog input here from this light resistor.
Absolutely. Thank you, CJ. So as CJ said, we are going to connect this to the analog pins, which are the ones down here. So just like with the button, we're going to connect it on the column between the photoresistor and the resistor. I'm going to draw a wire that goes from there all the way down to the bottom of the Arduino and to the analog pin, and I'm going to choose analog pin 0. And then because this is an input, I'm going to change the color of my wire to yellow. And nice and bright. And then I'm going to make it straight. Okay, that's better. Okay, and so now our circuit is complete. We've got our inputs, we've got everything going in a complete circuit, and we are ready to make it in real life. And once we've made it in real life, then we will start to code it. But while we're making it, do you have a think about how you think we might code it, thinking about how we coded the button last week? CJ, do you want to, I'm going to stop sharing my screen so you can see CJ big.
Yep. I'm going to go down to my, if you can see it all, yeah, that's all visible, isn't it? Yeah. Great stuff. Okay, so we're going to follow quite similarly to Sophie's circuit in Tinkercad. So we'll grab our 2 LEDs. And let's grab for now three wires, one of them being black. So we use that as the ground wire. And then 2 220 ohm resistors. I'll go through it all again as we go, but I'm just saying if people do want to get their materials prepared, all their bits and bobs now. That's 3 wires, 1 black, 2 LEDs, and 2 220 ohm resistors. Okay, right, so to start off, we're going to pop in our LEDs. So we're going to have the long, for some people who's already got the LEDs in their physical circuit, that's great, because that's what we want. We're kind of building on rather than stripping away. But just for those who haven't, or any newcomers, we're going to restart just putting the LEDs in. As you can see, my button is still in there, because this way, that once we add in more components, it means that we only need to change the code on the computer to be able to switch between either a button, for example, or an LDR. So if all the sensors are in, we can kind of just switch and go between the 2 different sensors. So that's why we do this sort of scaffold building on learning. Okay, so we've got the 2 LEDs. So one long leg, the longer leg, that's the positive. Going to put that into E3 and the shorter leg into E5. Also, if I'm shouting, I'm sorry. I can't hear very well out of my right ear, so everything's a bit muffled for me. It's a very strange experience.
It's coming across fine. It's all right.
Okay, great.
All right.
So longer leg into E3 and shorter leg into E5. Then we'll get our other LED and put long leg into E7 and short leg into E9. Okay, let's grab one of our 220 ohm resistors. And to find the 220 ohm, I noticed if you hold the packs up to the light, you can see that it has written on them 220 ohms and all the different types. So we're getting one 220 ohm one. And we're going to place one end into the shorter, which way around did I put it? There we go, yeah. Bear with me. One end into the short end of the LED leg. So that would have been E5 if you're following these ones, these coordinates. And then the other leg is going into the minus strip on the board. So one leg, shorter end of the LED, and the other end is going into the blue minus strip. Okay, we're going to do exactly the same for the other LED. So the shorter end was E9. So put one end into D9 and one end into the blue minus line. Hope that's, you can see that not very well because the lighting. Just about. Okay, so we have two resistors in now. Okay, now we're gonna pop some of our wires in. So we're gonna grab two different colored wires. And we're now working from the positive end of the LED. So that's the longer end, longer leg. So into D3, we're going to put one of the wires. And the other end is going into our pins 10 and 11. So let's put one into pin 10 now. One LED is being connected up to pin 10. So one end in D3 and the other end in pin 10 on the Arduino board. And then let's do the same for the other LED. So we've got one of the pins of the jumper wire into D7. That's the positive long end, long leg of the LED. And then the other one is going into pin 11 because they're the two pins that we're working with in this circuit. Okay, that's our LEDs almost done. Just going to pop a ground wire in. That will work for the LEDs and the LDR photoresistor that we'll set up shortly. So we're going to put one end of this ground wire black. I've used black. You can use any color, but I usually use black, but I often do change up as well. So however works for you, as long as you can see what's what on your board and Arduino. So one end into the blue line, and then the other end is going into the GND pin on the Arduino board. That's our ground connected. Okay, so this is exactly the same as Sophie's setup, but maybe different coordinates, but that's okay. We don't need to stay exactly the same. Okay, so now for our LDR resistor, our photoresistor here. The one with the really long legs, and it's got a little squiggle on the top, a little wave. Okay, so I'm going to put this next door to my button. Not directly next to it, but just close by. And I'm putting one leg, doesn't matter with the legs because they're both the same. One leg is going into E19 and the other one is going into E21. Right. And now for a resistor change, so we're not using our 220 ohms, we're going to use our 1000 ohm, our 1K ohm resistor, the same way that we did for the button. So if we grab that from our pack, and we're going to put one end in line with one leg of the photoresistor. So I'm going to pop it in now into D19. And I'm going to put the other leg into the blue minus strip of the breadboard, like so. Okay. So now we're going to use I'm going to use a red cable just for power, and the other end for positive. So I'm going to put the other one pin into D21, and D21 should be in line below the other leg of the LDR resistor. And I'm going to put the other end into the positive line on the strip. That's the red plus line on the breadboard. Okay. And I'm going to put take another wire and put one end into the positive strip of the breadboard. And then I'm going to put the other end into our 5 volts on the Arduino board. So that's 5V on the Arduino. Okay. And then finally, we've got to complete it. So we're going to, like Sophie's used that really long yellow wire in Tinkercad. I'm also going to use a yellow wire, not as long, but it's still yellow. And I'm going to put one end. I may just shift actually my resistors a bit close to the LD. One end of my resistors a bit close to the photoresistor. So I'm just going to move it down one. Staying in the same line, just moved it down a pin. So now I have a space between the photoresistor and one end of the resistor. So I've just put one end into C19 now of the resistor. So I've got a space here to put my yellow wire into D19. And this is the one where it's going to our analog pin. So all on the other side of the Arduino, it says analog in, and we're going to put it into pin A0. Okay, so that's our circuit complete. And I'll pass you back to Sophie.
Right, I'm just going to share my screen. But I'm going to try and share the... all right, so you'll remember that we're going to code over here, and we come out and we bring our code to the other side. All right. For some reason, I can't see any of you anymore, but I'm just going to believe that you're there. You are there, right?
Yes, we all are here.
Excellent, that's good. All right, so you'll remember we're going to start by using some of the same code, the same commands that we used for the button, but this time we're going to use the light dependent resistor, and we're going to add in some extra bits that are really useful. So you remember that the beginning bit is we want something to happen forever and ever. So we're going to go to the control block and have a repeat while loop over here. And we're going to repeat while 1 is equal to 1. So forever, basically. And that's our main block. And that's just going to happen forever and ever and ever and ever. All right. Now you remember that with the button, we use this really helpful set of commands called if, then, else. So we ask the Arduino a question, and then the Arduino does something depending on what the answer to that question is using the if, then, else button. So we're going to go and do the same thing, but we're going to use whatever the photoresistor is saying. So if you go to control again, you will find the if, then, else button over here, like this. And what we want to do is we want to turn our LEDs on. We're going to do this in a couple of steps, a couple of stages. We're going to turn our LEDs on if it gets dark. So we're going to use some maths to find out if the light level is higher or lower than a certain number. So you go to maths, and then you click that same little triangle thing. Is something less than something else? All right, and I'm going to actually change this. If the light and we're going to greater than, so the angle, the arrow sort of pointing towards the right hand side of the screen. And then we want to get that input, that value that our resistor is telling us, how light is it? So if you go to input, you'll remember that last time we used this read digital pin to tell us whether the button was on or off. Now, CJ and I have been telling you that actually now we want to use analog pins, because it's not just an on or off, it's a different number depending on how dark it is. So we're going to use this analog pin here, and we're going to pop that in our first section, read analog pin. So if the analog pin 0, if our light resistor, our photoresistor, is bigger than a certain value. Now we're going to cheat for a minute here, and I'm going to tell you a value to put in for Tinkercad. And we'll talk about how we can figure out what that value is later. So it doesn't really matter that you want to be around 450, say. So that means if it's really quite bright, okay, if it's quite bright, then we don't want our LEDs to be on, do we? So we're going to say, Arduino, is it bright? The Arduino is going to say, if the Arduino says yes, we'll do whatever is in here. And so what it's going to be in there is we're going to turn our LEDs off. So you remember we need to set our 2 LED pins to low. Click that to low, click that to low, and the pin numbers are pin 10 and pin 11. So pin 10 and pin 11. And if it's not very bright, then we want to turn our LEDs off. Sorry, we want to turn our LEDs on because it's dark and we want the lights to come on. So we're going to go to this. We just need to put this command in here, set pin to high. So send a command saying turn on to our 2 LEDs, and the 2 LEDs are pin 10 and pin 11. Right. Now, I've probably talked about this a lot before. It's always a good idea to test as often as you can with your code. And we can definitely make this code a lot fancier, but why don't we test it to make sure that it is working now, and then we can add the bits if we know it's working. All right, so give me a reaction. Kathy, we've been having a lot of fun with different reactions. There are some ghosts, it's very cool. Give me a reaction if you are ready to test your code on Tinkercad. Fantastic, Arish is there. Brilliant, and Palm, we're doing really well. We've got a, oh, Kathy's just discovered the party icon, the party reaction, and Sarah has a crown. Fantastic. How's everybody else doing? We've got some more people who are ready. Fab. Okay. All right. So let's start. Ooh, and I've just noticed that Laura has a shooting star reaction. I think that one might be my favorite. Let's start to simulate. So I'm going to start simulating in now, and it's thinking about it, and now my lights are on. So you can see, do you remember before when we pressed the button off and on, we just clicked it. If once you've started your simulation, you click on your resistor, on your photoresistor, you can move this thing to tell it how bright it is. So at the moment, we're pretending the photoresistor is saying it's really dark, this dark moon. But if I slide it up here, I'm getting close towards the sun, and you'll see as I get to about the middle point, my LED's turned off because the value that my photoresistor was saying was it's bright. So if you slide it up to here, it's bright and my LEDs are off because I don't need LEDs when it's light. But if it gets dark and I slide it back down this way, my LEDs turn on. All right, is everybody's working? Do we have LEDs that react on Tinkercad? Dane's works, fantastic. Well done, Dane. How are we doing it? If it's not letting you adjust the photoresistor straight away, oh, fantastic. We've got lots of people's working. So sometimes Tinkercad gets a little bit confused and it's like, I can't move anything. So what I do with that is just stop the simulation, click off onto another component, and then start the simulation again. Sometimes it just needs a little bit of a kick to get it going. Laura's is working. And so there you can see that again, it's up here, and I can change it to turn it off and on like that. Fab. Right, so now you've all done amazingly to get it working at the first attempt. Brilliant. But we did cheat a little bit there, didn't we? Because I just told you what number to put in here. And cheating is okay, and we definitely do help each other. But it would be good. It's good to know how to get this number. So we are going to use something that is incredibly useful called the serial monitor. And it's useful for finding bugs, finding problems in your code, and it's useful to find out how to do things. So I'm going to stop my simulation right here. We can use our serial monitor to tell us what value our photoresistor is seeing. Okay, so if you go to output, which I think we were on anyway, you'll see there are lots of different things, and one of them down at the bottom is called print to serial monitor. And so what we're going to do is we're going to take this out. We're going to pop it in the repeat loop. In fact, let's pop it at the top there. And at the moment, the command we're saying is print to the serial monitor. So essentially print to the screen, our computer screen in this case, the words hello world. And that's something that we do a lot in computer coding. It's often the first code that you learn how to write in it when you're doing a new language. But we don't want to print hello world. We all know Tinkercad. And so what we want to print is whatever this value is. Read this pin. So if you go back to input, you can get your read analog pin again. Remember to make sure it's the analog one, not the digital one. And just pop it in there. Okay. And then if you go on Tinkercad down to the bottom and you click serial monitor, you'll see something comes up like this. You get an extra little window. And we will see what happens when we start the simulation. So give me a reaction when you're ready to start the simulation, and we can all do it together. Oh, Lucas is there and having some lovely watermelon. Naya's there, fantastic. And Alexi, brilliant. Sarah's got a pumpkin. I like it. And Yusuf, fab. Well done, everybody. And do remember if we are going a little bit fast, if you've missed a step, all of the instructions are on the PDF that Dane sent, and you've got the recording to watch tomorrow or the next day. So don't worry if we are going a little bit too fast. So what we're going to do is we're going to press start simulation, and we will see what happens. So keep your eye once you press to keep your eyes down here. So I'm thinking about it, and you can see that it started to print some numbers, and that's saying that the value that my photoresistor is sending to us is 6. Now, if I change this by just changing my slider, you can watch as the numbers change. So over here, it's 323. If I move up, it gets a bit higher, it's 325. If I go here, it's 507, and you'll see that my LEDs are off. You can also look at it as a lovely graph, if you like. Here you go. So here's my graph, and you can see that it goes up and down and up and down as you change the light level like that. Now, this is really helpful because it tells us what value so if I say, actually, I don't want it to change around here, I want it to change up here. So I could look at that and say, right, that's 588. I could stop my simulation and say 580. Start it again. And now my LEDs don't turn off until I'm all the way up here at 600 or so. Okay, so has everyone got their serial monitor working? Give me a reaction if your serial monitor, if you're seeing the beautiful things. Fantastic. We've got some great ones working. Brilliant. Well done, everybody. Oh, and Dane, I really enjoyed the fact that the reaction that you chose was a graph. Thank you very much. That's pleased me a lot. I do like a graph. Fab. So this is helpful when we want to do this, but it's also helpful if you have a problem in your code. So if you think it should be the LED should be turning on and it's just not doing it, you can look at the numbers that it's telling you, and that will help you decide, that will help you figure out what is wrong with your code. You can put lots of different comments in it to find out what's wrong. Okay. Do we think it's time to send it to our physical Arduinos, everyone? CJ, do you want to share? Do you want to go from here to the physical Arduinos, or do you want me to do that?
Oh, yeah, I can take it to the physical Arduinos, because I was going to show do a little light experiment, just so they can do that maybe themselves. And awesome. Also I'll share my screen for the serial monitor on here. So
perfect.
Okay. So I'm plugging my my Arduino in now. And right at this moment, I've got quite low lighting in the space that I'm at. So, which means that my LEDs are turned on. So there's still a bit of light, but it's relatively low. And according to the code, when it's low light or no light, we have LEDs on, and that's what the LDR resistor is picking up. So right now it's picking up very low lighting, so that means it's on. However, if I bring some light over, if I shine some light on this situation, our lights go off. So when we have a lot of light, and on the serial monitor, you'll see the numbers change. And I can show you in a moment. I'll share the screen. I'll show you what that's doing on the Arduino app. So we have a lot of light right now. So which means no LEDs are on. And then, but if I put my finger over the LDR resistor, that's blocking all of this light that I'm shining. It's blocking it all. So the lights are coming on. And I can remove my finger and the lights go off again. And if I remove the lights also go off. So there you can see like the difference between dark light, no light and light, and that dictates whether our photoresistor turns the LEDs on or off. So the light coming into it is really affected by that. And when you have the code that you're going to input into your Arduino, I can briefly show you now. I share my screen, just going off what Sophie said regarding the serial monitor. You also have a serial monitor here on the Arduino, which you may or may not have seen yet. But if I share my screen, okay, I want you to see this one. Okay, so this is my code here that you will shortly have, hopefully. And if you go to the tools at the top and scroll down to serial monitor, that's the same idea that Sophie was using on Tinkercad. If you click on there, here there's also some comments inputted, so we know what we're looking at. So when we've got these range of numbers, so right now it's 104, 105. It's picking up that it's pretty dark in this area, so the LED lights are turned on. So they're on right now, and as you can see on the serial monitor, it's consistent with that. It's pretty dark, and that's our range. However, if I shine again the light over, as you can see on there, it's changing now. It's saying that it's average light, and then it's going to quite light. So it's really lightened up the space, and the numbers have shot right up to 489 and beyond. So that's how the LDR resistor works, and this serial monitor is a really good way of assessing with analog sensors, because you can really gauge between the number ranges. Okay, can you see now on the serial monitor?
Yeah.
Numbers. So right now it's saying it's pretty dark. It's about 96, 97, and we've got like LED lights on. And then if we shine the light over there, the LED lights turn off, and then it changes again. So we have average light and it goes right up to 250. So it can go even higher if you shine the light even closer. So the photoresistor is a really sensitive sensor, and that's why I love it. It's beautiful.
All right, everybody. If I just share my screen for a minute, we'll do this bit again. All right. So here we go. Here's my screen. And you'll see, so here's the circuit that we did. Here is our Tinkercad version, and here's our serial monitor in Tinkercad. If you go up to this bit that says blocks and change to blocks plus text, then you'll see another set of code. All right, and all you need to do is copy this code, and remember to copy all of it. So all the way down to every little bracket, because if you lose one of the brackets, then your computer will get really sad with you and it won't do what you want it to do. And then you just copy that and move it straight over to your Arduino IDE or into the Arduino app. Which one would you like me to use? Dealer's choice. I've lost the chat. The Arduino app, okay. All right, so if you go to the Arduino app, over here. Oops. So you go to the Arduino app. Is someone able to put the Arduino app into the chat for me? And then you click on code up here. And then all you need to do is paste the code that you had into your Arduino. Into your Arduino app. I wish they didn't call it Arduino, because then I say the wrong thing all the time. So now you should be able to see something like this. And it's just the same in the IDE that CJ was using before. You just paste it into that. All right. And then when you're ready, you plug in your Arduino using your, whatchamacallit, USB wire. And then you go down to the bottom here, the one that says serial. It might say serial device if you haven't done this next bit. And you should see your Arduino here. So you click on your Arduino, then you click connect. And then it should say serial connected, right? Okay. And then you don't have to do that bit in the Arduino IDE. Then you just click on this button here, compile and upload. Remember, that's the arrow that points towards the right-hand side on the Arduino IDE. You click compile and upload, and then it's compiling. That just means the computer's thinking. Oh, and it says error because I've done something wrong. I don't know what I've done wrong yet, though. So let's have a look. I think that maybe it got confused about the Arduino. So I'm going to connect again. Keep your fingers crossed, because this was working just a minute ago when CJ was using the other one. Laura has her fingers crossed, so let's see if that works. All right, so now if that happens, what you're going to do is I'm going to just try it again, because sometimes the computer gets confused about which Arduino it's talking to. I'm going to go back to the Arduino app, click on code, pop it in, select device. There's no device here. I'll plug it back in, and then it appears. Click on this, click connect. Yep, it says serial selected. Let's check it just to make sure that I haven't done anything silly. So that's checking it, but not sending it. Now, keep your fingers crossed, because I don't know why it's not working otherwise. Uploading code, and it's done. Hooray. And so with the serial monitor with the Arduino app, is really simple. You just click on this one that says monitor, and you'll see here that it's come up with some numbers. Now with the Arduino app, one thing you might need to change is, do you see this button over here? This thing that says 9600 board? I don't know. I don't actually know what that stands for or what that means. It means how quickly does the computer that we're coding on communicate with the Arduino. We just don't want it to be too fast. So if you change that to at least like 9600, not one of the tall numbers, one of the bigger numbers, then you should see the numbers coming up. Now you'll see that in the dark, in the light, my two LEDs are on. I'm going to have to turn my background off, aren't I? So you can see. In the dark, my two LEDs are on, except I just picked it up and now it's gone. My two LEDs are on. But then if I make it dark, I cover my light dependent resistor, it's not changing it too much because that number there in the light for my resistor is 150. So you remember I changed mine. So I'm going to change this to 100 here. Re-upload it. And you might have to change that number depending on how light it is in your room. Now, when it's dark, when I cover my resistor, my lights are on. And when I uncover it, my lights turn off. And bless you, Dane. All right. Has everybody got their physical Arduino working? Hooray! Someone said Eureka. I love it when people say Eureka. Fantastic. All right. Give me a reaction when if it's working, and if it's not, pop something in the chat. Hooray, we've got a thumbs up, it's working. Brilliant. Oh, did Sarah have a thumbs down? Is Sarah's not working? I'm sorry, Sarah.
I can't get Arduino to connect to my Arduino, but I might have missed a step, so I will rewatch the video and try and get it working later.
Okay. That seems like a good plan.
The same is happening with me.
Well, I think we're getting towards the end of it, the end of the coding session, so we'll move on to troubleshooting in just a minute. And if your Tinkercad works, then your code is right. And remember, it could either be something about uploading your code, or it could be, like I did, my resistor was not in properly.
Sophie, could you remind everyone how to do the same thing using the Arduino IDE instead of Arduino, with the choosing of the Arduino and things? I'm getting a few people giving me errors, and I'm not 100% sure what they are. So if we watch what Sophie does, it might hopefully solve some problems.
Let's see. Right. So I'm just going to unplug my Arduino just to stop it from getting confused. Okay, and share my screen. So this is the Arduino IDE. In fact, I'm going to unshare my screen and share it in a different way, because you won't see the serial monitor if I do it that way. There we go. All right, so here is my Arduino IDE. And just as in with the Arduino app, you delete what's there automatically, and you pop in a copy of your code from Tinkercad, okay? And if you remember, I changed this number so it was a bit lower, 100. So it turns on when it's actually quite bright. Okay, now you just have to press this button here that says upload. Do that. It'll ask you to think about it. And in my case, nothing's going to happen And the reason nothing's going to happen is because I did not plug my Arduino in. So remember to plug your Arduino in. That was the noise of my Arduino being plugged in. And that is the error that happens when you don't plug an Arduino in. I'll just check that I've got my Arduino. So if you click on Tools, and then you can go to this, you can see that board says Arduino Uno, which is what we all have, and port. I've got different options here, but I want to pick the one that says Arduino Uno. So it's right at the moment. Okay, so let's see if that works. So I click on this button that says upload. Thinking about it, uploading, and now it says done uploading. And my circuit is working again. Oh, sorry, you don't have to just take my word for it, look. Awesome. And now you'll remember where CJ showed you the serial monitor. So if you go to Tools here, you've got this button that says serial monitor. Click on that. Can everybody see the serial monitor? Yep, fab. And now I'm putting my finger over the code, over my Arduino. You'll see it go down. And if I take it up, it goes up. So it's 190. And if I do it down, it gets darker. Okay. All right. Did that help? Fantastic. I don't know who, but someone just said the serial monitor worked. And we've got some rocket ships, which I'm assuming means hurrah. Fab. Sarah has a bright sun star. Fabulous.
Just whilst we're waiting, Sophie, for any more reactions, I showed them a little glow in the dark star that I've created here. You can sort of see it. So it's light right now. We need to get it dark again. Bear with me. The light's not working now, but the star was basically, I created this star. Basically, it's very simple, out of 2 bits of foam, and then you put one in front of the LED and the other one behind it, and it closes the LED in place. And next week we'll show you how to extend your wires so that you could create something like this. So little glow in the dark stars. Not sure why my light stopped working, but yeah, this is the little stars. So you can use any material that's sort of semi-transparent and attach one front to the front of the LED and one to the back, and it creates a nice luminous glow in the dark star.
That's great. Well, there's loads of options for people to do creative things. So we're getting close to the end of the session. And so if anybody wants to have a bit of extra help with some troubleshooting, I think it'd be a great idea for you to stay. It's really been nice to see some creative examples from CJ. It's been really good to see. I'm going to turn my background off and just demonstrate that I've done mine too. Yay. So here we go. I've got mine. If I cover it, it lights up. So that's hopefully what it will look like. And if yours isn't doing that, stay behind and we'll help you. But otherwise, thanks so much everyone for coming. It's been a really good session learning how to use a LDR or a light sensitive resistor or a light dependent resistor to see whether or not we can change things without even physically touching them ourselves. So that's wonderful. Thanks CJ, thanks Sophie, Sarah, and Laura. It's been good to see you, and Kathy as well. And we'll see everyone next time.